Okay, so we're going to talk a little bit about scientific notation, and that's important because it lets us write really large numbers or really small numbers in a convenient way, and we can you do calculations with them more conveniently. So let's look at a big number like, let's make one up. And it's not a super big number. You could put that in a calculator. But to write it in scientific notation, you have to take the decimal at the end, and you're going to move that till it's got one digit in front of it. So it's going to be 1.23, and then it's going to be times 10 to the, and then how many places did you move it? 1, 2, 3, 4, 5. 10 to the 5th power. Okay, so that's how we write it in scientific notation. It's one time when we use the multiplication symbol with the X. Some textbooks I've seen not use that, but most textbooks use the X to indicate scientific notation like that. So what you're saying is 1.23 times 10,000, and that would get you 123,000, okay? A couple things about scientific notation. Let's say I had tried to write 12.3 times 10 to the 4th. You're like, nah, I'd rather have a 12. No, that's not scientific notation. So it's not that it's not true, that it's not the same value, but it's not considered scientific notation. Your number has to be, when you have a times 10 to some exponent, that a has to be greater than 1 and less than 10. And it's the absolute value. It can be negative, and you're okay. All right. But you can't move the decimal too far or not far enough. Like if you tried to put 0.123 times 10 to the 6th. Again, the value works, but it's not considered scientific notation. Okay. Now, I mentioned having a negative number. Let's say you have negative 45 million, something like that. Okay, then you can write that as negative 4.5 times 10 to the 7th, right? There's 3, 6, 7. Okay, so it's how many decimal places you're moving to get that 4.5. All right, those were big numbers. Well, I guess negative 45 is a pretty small number, but those have positive exponents. Now, what if we have a little number like 0.00012? Then we're going to count to the right, 1, 2, 3, 4. So it's going to be 1.2 times 10, but we're moving to the right, so it's going to be negative 4. It's like you're multiplying by 1 over 1,000. Okay? All right. So that's just a little bit of scientific notation, but we'll do some converting, and that'll help make it a little clearer. So we're converting standard notation, so some number with all the zeros, to scientific notation. All right, so the distance to Andromeda Galaxy from Earth, 24 and a bunch of zeros. So I'm going to make it 2.4 times 10 to the, now I have to figure out how many places. 1, 3, 6, 9, 12, 15, 18, 21, 22. Let me double check that. 1, 2, 3, 4, 5, 6, 7. That's 21 zeros. And then there was one more place. So yeah, I think that's right. That's written in scientific notation now. 2.4 times 10 to the 22nd power. All right, diameter of the Andromeda Galaxy. All right, it's going to be 1.3. By the way, these were meters. I guess I could put the little m for meters. Okay, 1.3 times 10 to the 1, 2, 3, 4, 5, 6, 7 place. Okay, 21st. Okay. That's how you'd write it in scientific notation. Number of stars in the Andromeda Galaxy. Okay, now at this time it's a 1, isn't it? You could, now I'm trying to think if they usually write 1 times 10 to the, let's see, 12th, or if they just write 10 to the 12th. I think they're going to write it this way, but I'm going to look it up. Okay, so I looked it up. They do have it this way. Those are the same value, by the way, but to be consistent with the scientific notation, the 1 times 10 to the 12th. So I'm going to change my rule up here to be A has to be greater than or equal to 1. Okay. All right, now we've got some small numbers. Now, I noticed that the book typed it this way. That's really hard on the eyes. Another way you can type it is to put like, we don't put commas, but they'll put like a little space in between sets of 3 zeros. So, you know, I prefer to type it this way, but just so that you know, the book types it this way, but either way. So it's going to be 9.4, because we have to get that number that's in front of the multiplication symbol between 1 and 10, or it could equal 1. All right, then how many places did we move? 3, 6, 9, 12, 13. Now you're going to make that a negative 13 because you're moving to the right. It's a small number. So I think of it this way. Big numbers, positive exponent on the 10. Little numbers, negative exponent on the 10. Okay. I should probably double check and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. You're just moving that decimal. All right, and then this one we have 1.43 times 10 to the negative 1, 2, 3, 4, 5, 6. All right, so large numbers and small numbers, writing them in scientific notation,